Welcome back, students. We're going to be looking into modeling with quadratic functions. Now, depending upon the situation you're working with, you might be given different kinds of data. So, for instance, if I am given a point and a vertex, then I'm going to default to using my vertex form to write the model for the quadratic equation. If, however, I'm given a point and some x-intercepts, then I'm going to approach this differently, and I'm going to use my intercept form. If I am given 3 points, then I am likely going to, using my standard form, create 3 different equations in which my variables are a, b, and c from a squared plus b ax squared plus bx plus c, and I'm going to substitute in my values for x and y and then create a system of 3 equations and solve for a, b, and c. Okay, but it all depends on what are you given? What have you started with? And that's going to help us determine which model, which equation is going to be most easily used or most appropriate for the situation. So here we have a graph that shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. We want to write an equation of the parabola. The performer lands in a net 90 feet from the cannon. So, what's the height of the net? So, it looks like they're asking us to find that point right there. Okay, so let's look at what we were given. It looks like we were given the vertex of it, so we know how far he went when he reached his peak and how high that peak was. So given that I know the vertex and I know a point on the graph, I'm going to use my vertex form. So that is y is equal to a times x minus h squared plus k. So, some things that I know from this. H and K help me to identify where the vertex is. And my vertex is at 50 and 35. So that is H and K. So A times x minus 50 squared plus K. The only value I don't know yet is A. So the way we're going to figure out A is by using the other point that they gave us. So when x is a 0, y is a 15. So let's set y equal to 15. X is going to be 0. And now we begin to simplify that equation. So that's going to give me a 2,500 A, and then we've got, I'm going to minus the 35. Well, no, we'll just leave it this way. So plus 35. Now add the 35 over, or subtract it over, and we're going to get negative 20. So then A, after we divide out 2,500, we get negative 0.008. So the equation for this is going to be y is equal to negative 0.008 x minus 50 squared plus 35. Fantastic. Now, we know that they landed in a net 90 feet away from the cannon. So the distance from the cannon, that's x. And they want to know what the height of it is. Well, that's y. So we're going to substitute in the 90 and then we'll have 40 squared plus 35. And let's go ahead and we could easily type that into a calculator and we would get 22.2. All right, so we know that that is feet, and that right there is how high the net is, at 22 feet. All right, so that wasn't too bad. Knowing the vertex and a point, we were able to easily get at those values and then even use our equation to start calculating other locations. All right, let's look at another. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature. We want to write a function that models the temperature over time. What is the coldest temperature? All right, so let's look at what we have. I don't know what the vertex is, but I do know two of my roots. So what I'm going to use is the factored form, which they call intercept form. And so let's go ahead and start with that. Y is equal to a times x minus p and x minus q. So p and q are going to be the values of our roots. So at 4, we need to have a 0, and at 24, we need to have a 0. So this is going to be a x minus 4 and x minus 24. So now we need to figure out a. In order to figure out a, we're going to use this other point that they gave us. So y is equal to a times, since x is a 0, so 0 minus 4, 0 minus 24, which should give us 96a. And the y should have been a 9.6. So let's go ahead and erase that. That should have been 9.6. Dividing by 96, we get that a is a 0.1. All right, so now we know the equation is 0.1 x minus 4 x minus 24. And they're also asking, what is the coldest temperature? All right, well, in order to know the coldest temperature, we need to know the exact location of the minimum. Remember that quadratics are symmetric, so we need to know what is the value right in the middle of our 4 and 24. Well, 24 plus 4 is 28. Half of that is 14. Okay, so 14 is going to be our axis. It's the axis of symmetry. All right, so now that we know our axis of symmetry, we can put it into this equation to then figure out what is the value, what is the coldest temperature that there was. So y is going to be equal to a 0.1. The x is going to be 14 to give us the minimum. 14 minus 4 14 minus 24. We can put that into a calculator, and it's going to give us negative 10. All right, so that is the coldest temperature. All right, let's look at what B is asking. It's asking what is the average rate of change in temperature over the interval in which it's decreasing, increasing, and then to compare the different rates. Okay, so let's look at where it's decreasing. It's decreasing from 0 all the way till 14. So an average rate of change is basically the slope of the line that goes from there to there. And that's what we're trying to figure out, is the slope of that line. Luckily, we know the exact point right there. So that is a 14, negative 10. Oh, I guess we didn't even need to type it out. We can kind of see on the graph it hit at negative 10. Anyway, let's now go ahead and find that slope. So the change in y, we went from so we're doing 10 minus 9.6 over the change in x, a 14 minus a 0. Okay, and that will give us negative 19.6 divided by 14, negative 1.4. All right, so this is for the decreasing. All right, let's do this for increasing. So we're now using these 2 points. So change in y, 24 minus the 14, all over change in x. Oops, I did use the x value right there. All right, sorry, 0 minus negative 10, and then that will be over 24 minus 14. Change in y over change in x. All right, so that'll be a 10 over 10. So on average, it's increasing by 1. So what we can say is that prior to 2 o'clock, that's 14 hours after midnight, prior to 2 o'clock, it seemed to be decreasing faster than it was increasing after 2 o'clock, at least as far as this graph shows. All right. I hope this helps. Good luck on your practice.